So, NASA just dropped a bomb. They found a new planet. Crazy, right? The James Webb Telescope, super powerful piece of tech, spotted it hanging out beyond our solar system. Esther Bauer over at Fox 35 is breaking down how finding this planet could clue us in on, well, everything. Back in July 2022, Webb sent back this insane picture of space. It was so detailed, so old, it was like looking back 13 billion years. For ages, scientists have been trying to figure out the early universe, using the best tools they had. They came up with a pretty solid story based on the Big Bang, cosmic expansion, and all that jazz. But Webb? It didn't just give us a clearer view. It basically blew up the old textbooks. One discovery after another started poking holes in what we thought we knew, pushing physics to its limits. This wasn't just a new chapter. It was a whole new book. Before we get started, hit that like and subscribe. The first shocker? Galaxies. Webb found these huge, fully formed galaxies super early, just 300 to 400 million years after the Big Bang. They shouldn't have been there yet. According to the usual models, galaxies were supposed to form slowly, with stuff gradually clumping together. But these galaxies looked mature, dense, and were pumping out stars like crazy. What really blew scientists' minds was how huge and bright they were. Some were as big as our Milky Way, which is nuts for something so young. And it wasn't just a fluke. Webb kept finding them. Every time they looked, there were more of these cosmic giants where they expected to see tiny fragments. Either we're way off on how galaxies form, or something's messed up with how we're reading cosmic expansion. Either way, it's a big deal for how we've understood physics for the last 50 years. Then came the stars. Webb's infrared vision can see straight through space dust, giving us a clear view of some of the first stars and galaxies. And what it saw didn't match the Dark Ages idea, that empty period after the Big Bang. Instead, starlight was all over the place way earlier than expected. The timeline we thought stretched for millions of years before stars really took off looks way shorter now. Star formation seemed to kick off almost immediately, and like nothing we predicted. Cosmologists are scrambling to explain it. Maybe star formation was faster than we thought. Maybe the first stars burned hotter and faster than our models show. But even those ideas are a stretch. Trying to fit these finds into the old framework is like trying to shove a square peg in a round hole. And Webb wasn't done yet. It started checking out the air around planets far, far away and found chemicals that shouldn't be there based on how we think planets form. On gas giants hundreds of light-years distant, Webb detected complex stuff like water, methane, and carbon dioxide in amounts that don't make sense. It's not totally rewriting physics, but it's shaking up how we think planetary systems grow up with their stars. But it was Webb's work with the overall structure of the universe that really smashed old theories. Big surveys of the early universe showed it was smoother and more organized than anyone thought. There were massive threads of stuff, cosmic highways stretching across space. Already they're less than a billion years after the Big Bang. We thought these things formed slowly as gravity did its thing, but their early appearance is messing with our understanding of gravity itself. Either gravity worked faster than we thought, or the universe started with different ingredients than we assumed. Even more confusing were the implications for dark matter and dark energy. For years, dark matter has been this invisible stuff we need to explain how galaxies move, but Webb's seeing less dark matter than we expected in the early universe. The gravity we're seeing in these early galaxies doesn't quite fit the models that need tons of dark matter to hold things together. If dark matter isn't doing what we thought or isn't needed at all on this level, then a huge chunk of modern physics is in trouble. Dark energy, that mysterious force making the universe expand faster, is also being questioned now. Webb's data hints that the early universe expanded at a different rate than we thought based on previous measurements. This makes the Hubble tension, this disagreement about how fast the universe is expanding, even worse. Before Webb, it was a minor issue. Now it's looking like a major crack. Each new bit of data from Webb is chipping away at our confidence in the old ideas. It's not just about tweaking numbers. The telescope is exposing cracks in the foundation itself. Physics isn't supposed to be this flexible. Einstein's theory of relativity, the usual model of the universe, these weren't just ideas. They were practically law. And now they're looking shaky. Because of all this, scientists are seriously considering some wild ideas. Stuff that used to be on the fringes is now getting a second look. Maybe our understanding of gravity is wrong. Maybe gravity acts differently on a large scale. Or maybe we're totally wrong about time and space. Some people are even saying we might be seeing evidence of a universe that goes through cycles, with Webb catching glimpses of a past version of the cosmos. Others are thinking even bigger, suggesting that Webb isn't showing us physics breaking down, but the limits of physics. That there's a point where our laws just don't apply. Weird concepts like quantum gravity and string theory are now being looked at as ways to understand all this new chaos. It's not just a small adjustment. It's admitting that we might need a whole new kind of physics, a revolution on par with Einstein. The stakes are high. Physics depends on things being predictable. When the universe stops behaving as expected, it means we're missing something big. It's not just that the numbers don't add up, but that our questions are based on ideas that might be totally wrong. The James Webb Space Telescope didn't just give us better answers. It's forcing us to ask completely different questions. The big takeaway is that the universe doesn't have to follow our rules. For years, scientists thought that the more we looked, the more the universe would neatly fit into our existing models. But Webb's showing us a cosmos that's weirder, older, more organized, and more unstable than we ever imagined. It's showing us that the universe isn't a patient teacher, slowly revealing its secrets. Sometimes, it screams a truth so loud it breaks the tools we've been using to understand it. This isn't the first time something like this has happened. Galileo's telescope showed us that the sky wasn't perfect. Newton changed how we think about motion. Einstein reimagined time and space. Now, Webb's in that same league, changing the game with a view of the universe unlike anything we've ever had. It's not just improving our view, but challenging the rules themselves. Everything's being reevaluated. Cosmologists are rethinking cosmic inflation, the superfast expansion right after the Big Bang. If big structures formed too early, maybe expansion happened differently or not at all. Maybe something else created them, something we haven't figured out yet. Meanwhile, particle physicists are worried about their own models. If dark matter isn't what we thought or isn't even there, then all those experiments might have been chasing the wrong thing. Webb's not just looking into space. It's shining a light on the blind spots in modern science. For scientists, it's exciting and disorienting. Webb has handed them a puzzle box wrapped in infrared light, with no easy answers. But that's what makes it so exciting. Science is about dealing with surprises, and progress comes from facing challenges, not from being comfortable. Webb hasn't broken physics. It's energized it, forcing it to change and making us rethink everything. It's a new age of exploration, not just of space, but of understanding. The universe has spoken again, and it's telling us that our story isn't finished. For the first time in a long time, the cosmos feels not just big, but truly unknown. And that's the biggest discovery of all. As the James Webb Space Telescope peered deeper into the early universe, a new mystery started to pop up. It wasn't about finding totally new things, but about small disagreements between what Webb saw and what our theories predicted. These differences didn't totally break physics, but they hinted at stuff going on behind the scenes. It was like hearing a few wrong notes in a song that suggests the song is different than you thought. Webb started spotting early black holes, really big ones, hanging out in the centers of galaxies that were only a few 100 million years old. These supermassive black holes, some with millions or billions of times the sun's mass, shouldn't have existed so early. The usual ideas say that black holes start small and grow over billions of years. But these black holes seem to be ahead of schedule. To form giants so quickly, you'd need something different, like black holes forming directly from collapsing gas clouds or new physics to bend some old rules. Something more radical had to happen. At the same time, new light curves started hinting at strange behavior in star clusters and galaxies. Webb saw changes that suggested previously unseen stuff happening inside early galaxies. Some of these changes suggested short-lived processes switching on and off too fast for our old models. Were early supernovas acting differently? Were gas clouds flaring up faster? Or were there totally new sources of energy? These weren't just theories anymore. Webb's clear observations had made them facts. Meanwhile, the telescope looked at the space between galaxies and started finding chemicals we didn't expect. Heavy stuff that should only form inside stars was showing up more than expected. This meant that the way heavy stuff is created happened much faster than we thought. If this stuff was all over the place so early, then stars must have lived and died really fast. This quick recycling of stuff suggests a fast-paced start and stop of things that's unlike anything we knew, one so fast that we might have to rewrite the story of how the cosmos grew. The cosmos feels different now. Not slow and steady complexity. It was a storm of activity nearly from day one. One of the weirder things that came out of this was the need to rethink some so-called constants of physics. Things like the strength of gravity, how fast light moves, the tiny structure stuff that have all been assumed never changed, we started questioning. They're the base levels of physics, the numbers that make sure things worked the same. Yet, some details from Webb's pictures suggested that light may have been acting differently back then, like it was interacting in some different level. These differences were teeny, like fractions on top of different fractions, but consistent. Lines shifted in weird ways, signaling that, in those times, those fundamental numbers shifted some. If this is true, universal law doesn't exist anymore. Physics codes can change, and the now-called constants are now local rules subjected to time and space. This opened doors to even weirder possibilities, one that suggested, like water, the universe has phases, as in, different laws came into being. Space even became a focal point, with gravity theories taking up speed like emergent gravity. Not a fundamental force, but a macroscopic phenomenon from micromates. In essence, gravity, like temp, is an illusion. Why isn't our universe in sync, or acting like we thought it would, based on old dynamics? Einstein was only half right. We're using adult measurements to describe child universes. No wonder. Were we wrong about time too? A start and end? But quantum suggests it's not fundamental. Webb's vision that showed us these origins of light raised questions if time existed in early frames, and suggests we could be flawed in our processes. Maybe there was no Big Bang, but we are only seeing the moment of symmetry transition, but of time, not of energy. Our pictures from long ago show the direction of the birth of time, or a transition from light speed, rather. So now we have cosmic expansion, more specifically that the universe expanded over a fraction of a second as a theory. But Webb found some mess-ups with the homogeneity here, or that inflation has occurred or not. But back to space, Webb gave us gravitational lensing. With light bending round things, were we seeing errors? Is this space-time curvature? Well, maybe, if quantum or string theories tell us space ain't smooth, it's units or vibrating strings. Webb may be showing us the evidence here with light scattering or focused. Space ain't the backdrop, it's part of the show. A dynamic field. There are some questions around cosmic symmetry too, with galaxy clusters and more, suggesting maybe, with higher densities we have local curvature in dimensional structures. The anomalies call for an answer, with exoplanets being mapped and all these elements of building blocks. Like formal acetylol scientists saw them around young stars. That was a we wouldn't expect this scenario. Sure, its existence, but not so muchness. Is the cosmos life-friendly this way? The potential is what we need to factor in. We went spiritual and now we're in spectral, that could have once been the void. Did you know we're stuck still with our paradox? So there is either life or there isn't, period. We're not in the absence category, but it's misunderstanding this cosmic phase. James Webb has unlocked the universe in short, and is going through physics, thermodynamics, and more. And rewriting history, he's hinting that it's only the beginning. Every pixel is going beyond what the visuals show to space-time. We just have a sense of humility, as we're so tuned to wild, emerging recursive models. It reminds us discoveries are pure beginnings. We are at an apple tree and speeding trains. Beauty. Physics doesn't obey. In its silent orbit in deep space.